Okay, let's have a look at a third example here. Now, I think it's getting a little bit more complicated, but once again, we've really got a node here, which we'll call the V1 node. We've got a node here, which we'll call the V2 node. And we've got a node over here, which is really the same point here, which we're going to call the V3 node. And then, of course, this is our reference node sitting over here. So that's our reference, which is at 0 volts. Okay? So let's start writing down our node equations. All right, let's look at the V1 node. What do we have? Well, coming in, we have 2 milliamps. We'll define a current in this direction as being, well, of course, it's going in this direction, so it's a minus, and it's V1 minus V2, and it's divided by what? 1K. We've got a current coming into that node, which is this, what, 4 milliamps. So that's a plus 4 milliamps. And then, of course, we've also got this current going in this direction here, which we're defining as what? A minus, and that would be a V1 minus the V3, and that's divided by the 4K. And I think we've got everything, and so all of that is equal to 0. Okay, that's our first V1 node equation. Let's look at the V2 node equation. So this is V2 node. All right, what have we got? Well, starting here, we've got 4 milliamps coming out, so we can say it's a minus 4 milliamps. Current in this direction would be what? A minus V2 over 2K. Current going in this direction would be a minus bracket V2 minus V1, so that's a V2 minus V1, and that's over what? 1K. And then the current going in this direction would be what? A V2 minus V3 divided by 500. So that's a minus, and then it's V2 minus the V3, and that's divided by the 500. And that's it, and all of that's equal to 0. So that's our second node equation. All right, third node equation. So this is the V3 node. Let's have a look at that. Well, coming in, we have what? 3 milliamps, okay? Going out, we have the V3 divided by the 3K, so that's a minus V3 divided by 3K. Coming out, we have a minus bracket. This would be V3 minus V2, V3 minus V2, right, divided by 500. And then also this current here, which is a minus going in this direction, would be a V3 minus the voltage on the other side, which is of course V1, and that's divided by that 4K, and all of that really is equal to 0. So look, once again, I think once you get the hang of this, it's pretty easy really, isn't it, to actually write down your node equations. And just to reiterate, you're just doing what? You're just summing currents really at each of the nodes. That's all you're really doing. As I said before, this is the circuit analysis. This is the nodal analysis. If you wanted to solve this, then you'd collect your terms together, you'd end up with 3 simultaneous equations, and you could solve for V1, V2, and V3. Look, I'm not going to do that here. I'll let you go ahead and do that if you so choose. But this is yet another example. So hope this is getting easy for you, and I'll see you next time.